My name is Michale Glennon. I'm a senior research scientist at the Adirondack Watershed Institute at Portsmouth College. I am a wildlife ecologist by training. The project that I have here is a data art project where we're using fiber art, in this case, to basically tell the stories of our waterways in the Adirondacks and the Lake Champlain Basin. It's just a tool for environmental education for us, but it's been so well received that we've built it into a bigger project than I ever dreamed, which is great. That piece, yes, is a representation of the Lake Champlain ice record. It goes back to 1816. That's a data set you can just get online and find easily. And it works really well because it's a binary data set. It's just, did the lake freeze or did the lake not freeze? Because that's a big enough lake that, we may not get complete freezing. And so each row in that piece is a year since that time, and the way that I and others have represented it is to use white or gray or light, icy color for years that the lake froze, and a darker color for years that it didn't. And so if you look from the beginning to modern times, you can see that there's a lot more bands of darker colors for years that the lake didn't freeze entirely. That's also one that several people have done. Mine has kind of a wavy stitch pattern. I did it in Tunisian crochet. Others have done it in knitting. Others, we have one that's just plain garter stitch straight, no waviness. So again, multiple interpretations, but that data set of two colors, did this thing happen or did it not, is a really easy one, I think, for people to see, because you can very easily pick up the change from one end to the other. The piece that I made also has some beads in it that represent in the years when it did freeze. Todd put a bead in one of 3 columns of whether it froze in December or January or February. We did a very small one at the Portsmouth Visitor Interpretive Center with 6 or 7 items. That was just up for a couple days, but Jill, who was the Tawny director at the time, Jill Bright, saw it there and said she wanted to bring it to Tawny, which was wonderful. So from there it sort of became this true exhibit. The Mirror Lake Ice Record, which is represented in Joy's piece, that with the loon, and that, she has sort of the graph there and the loon, which hers brings in the interesting factor of sort of what the impact of the changing ice conditions on Mirror Lake, how that impacts common loon. In that instance, it's also represented in Sarah Bertoman's sweater, which is one of the ones that's in the exhibit. That has the ice record across the bottom. There's another piece I don't have anymore, which I did have for a time, rug hooking, piece that represented the same data set, just in a different interpretation.
My name is Joy Muller-McCoola. I live here in Glens Falls. I'm a wet felter predominantly. For the piece in this wool and water show, I needle felted and then wet felt finished. Michale had public open house about the Wool and Water Project in Lake Placid, town. And we headed up to Lake Placid to see what this was about, because most of my wool pieces look like water or stones. And it was very interesting to see what was being done. Wet felting fibers can move more generally, so I wanted to think about how to get all the specifications in there exactly. But then I was hearing about loons that had been iced in on the lake because they hadn't left early enough. Because the ice-in dates are later, the loons, especially the juvenile, inexperienced loons, aren't getting the message it's time to take off. Loons need a quarter mile of distance to take off. They don't have hollow bones like other birds that we're familiar with. So as that ice-in date gets later, but then suddenly there's a deep frost and the ice forms on the lake, they're caught stranded. So I started drawing loons taking off and abstracting it in the way that I used to paint, meaning just a little bit of cubism breakup of surfaces. And then I blew up this information to the size of the finished shrunk down felt so that it wouldn't get distorted. And then I plotted it out with pins through the drawing and needled in the graph. which doesn't, of course, have the dates or time, but you can still see that there's this warming trend.
The Adirondack Watershed Institute is about a 30-year program of Paul Smith College, and we're focused really strongly on protecting clean water and healthy watersheds. My own research is primarily terrestrial, but we do have a large team of folks that does long-term water quality monitoring, and another large team of folks that does aquatic invasive species spread prevention. Those are two of our sort of flagship programs that people know us very well by. That is one of the biggest things that we do at AWI is aquatic invasive species spread prevention. We have a very large stewardship program. We hire about 120 boat launch stewards. In Lake George in particular, and also Lake Champlain and some of these lower elevation, bigger lakes on the edge of the park, you unfortunately have the geology that can support things like zebra mussel, because that's an organism that needs sort of the higher calcium substrate that is present more over here. We're kind of lucky that most of the lakes are in the more interior parts of the Adirondacks are too acidic to really support big populations of zebra mussel, but in Champlain and Lake George, that is a concern. There are other ones that, like water chestnut is another example that is, primarily in Lake Champlain and some other spots in those bigger lakes. So water chestnut, zebra mussel, and Asian clam are three of the ones that are represented on those necklaces, because they have these hard-shelled things that I can put on a necklace. Plankton are natural components of ecosystems, but what that piece is about is changing plankton communities in Lake Champlain based on some research at SUNY Plattsburgh that is showing that nutrient pollution in the lake and other things, potentially climate warming, are shifting those communities sort of away from a broader diversity and abundance of zooplankton species toward a higher prevalence of blue-green algae, which are phytoplankton, and in particular some of which can cause harmful algal blooms. So if you look at that piece, I guess even left to right, it starts with sort of more pieces of that multicolored, my examples of what zooplankton might look like, and it shifts toward the more blue-greenish color toward the other end. There's just a higher dominance of that blue-green color, and that's meant to represent a shift toward more blue-green algae, or cyanobacteria is another name for those organisms, and those are the ones that can cause harmful algal blooms. Those are data from the Jefferson Project, which is long-term monitoring on Lake George. That is Lake George Association and RPI, and they have all sorts of, I won't even get all the details right, but all sorts of continuous monitoring on that lake that is looking at a number of parameters. You can get a wonderful amount of information about Lake George, and one of the things that you can get right on their data dashboard and learn about is chloride. And so we use chloride on the roads in the wintertime to make them safe. So NaCl, like high school chemistry, right? Sodium chloride is the compound that we use. It's just salt, the same way that we use on our tables. And the data are just what I pulled off of their website for levels of both sodium and chloride, those two increasing in Lake George over time. So that piece doesn't have any specific data, but what it is depicting is the things that you need to make a hab. So the recipe for a hab: sunlight, warm, calm water, nutrients. There's a sun, which is warming up the water. There's a few rows where they can see the temperature sort of changing from cooler to a warmer color. There's a section where it's kind of wavy, meant to say it's too wavy for a hab, and then it gets calm. So there's your calm. And then in the final sort of chunk of it, there are beads that are meant to represent nutrients, something like phosphorus, for example. And once you have sunlight plus warm, calm water plus nutrients, those are the perfect conditions to create a harmful algal bloom. Along the edges of that shawl are pieces of bright green roving that I sewed on there to represent harmful algal blooms. I think the combination of art and science is more natural for us than we think. And because I think fiber art is so meditative and it has proven the health benefits, I think it can help us work through, in the way that lots of other forms of art too probably do also, helps you work through thinking about some of these environmental challenges that are tough. I have a couple of pieces that use data from my own work. There is a triangular shawl called the Racket Wrap that represents two different aspects of things happening in Racket Lake, one of which is my work and one of is my colleagues' work. So there is the blue sections of that triangular wrap are information on how transparency in Racket Lake is changing. So that's basically when you use a Secchi disc and you drop it down in the water and look at how clear the water is, essentially, like how far do you put the Secchi disc down before you can't see it anymore. That's that black and white pattern disc. So lake transparency in Racket Lake is decreasing, and it is decreasing in a number of Adirondack lakes. On the edge of that is data in greenish colors, and that pertains to birds that live in all of the inlets and outlets off of Racket Lake. There's the Marion River Fen and the South Inlet Fen and the Beaver Brook Fen, and all these spectacular boreal wetland habitats that I've had in my long-term boreal bird monitoring for many, many years. So these are birds that are Canadian bird friends of ours who are widespread in the northern Canadian boreal, and they're just on the edge of where they live in the Adirondack Park. We are lucky to have them. They breed in the park, but they're adapted to a northern climate, northern kinds of systems, and in our case that is these pockets of boreal wetlands that kind of look like somebody took you and picked you up and deposited you many hundreds of miles to the north in the Canadian boreal. They're just, wonderful sphagnum, black spruce, tamarack boggy kinds of places. Racket Lake has that kind of habitat in all those inlets, and I have had bird transects in there for years. And so the data in the green part of that shawl is from my work in Racket Lake, which coincides with my coworker limnology colleagues on Racket Lake, and it is just showing changes in those birds. And it's not the same in all of those inlets and outlets to the lake, but it is a decline for those birds in general in many places around the Adirondacks, and that's probably because of climate change. The boreal bird data is represented in the Racket piece. It's represented in the earrings that the one person we have that did beading. It's represented in another piece called Meacham Lake Birds that one of our participants, Renee, made. That is the same effort. It's same long-term peatland bird monitoring, and in that case it's in the Osgood River south of Meacham Lake. I am not an ice fisherman, but I really, really love living in a place where ice fishing happens. It just, I love to drive past lakes in winter and see the ice shanties out there. And in my fantasy world, when I retire someday, I will become an ice fisherman. And so I really wanted to do a piece on ice fishing. And so that piece has data for the Northeast, so it's relevant to our lakes. It is, again, a record of winters, in that case since 1899, with each hole in it representing one of those winters, or a hole in the ice if you see the world the way an ice fisherman does. And then there are some of those holes, again, if you think about the top of it as the late 1800s, and then down at the bottom, more modern times, there are some that I put blue embroidery around the edges of. And those are the winters where the mean temperature was above 25 degrees, and that's the temperature at which we often have to cancel ice fishing derbies. It was made from a pattern called Swiss cheese scarf. It's just, garter stitch with a bunch of holes in it, which I thought was a great way to make it look like holes in the ice. I used white yarn, and then I knitted it, and then I felted it because I just thought that would make it look kind of neat. I really like to felt things, and then I did the embroidery after I felted it. And so we took some pieces around, and we did workshops and little presentations, and right from the get-go said, please, if you like to do this kind of thing, we'll help you do it. And so right from the start, it was a thing that we wanted to have other people involved with, because fiber people, they just love to make things together, I think, as much as they love making things.